This video is part of an online course of multivariable calculus, and I would like to talk about polar curves. What are polar curves? We can use polar coordinates to represent curves in the plane. So let me start and tell you how to do it. First, I'm gonna talk about polar curves. What are they? We can use polar coordinates to describe curves in the plane. So polar coordinates is just two coordinates, they are just in the plane by polar equations. What is a polar equation? A polar equation could be something like this: r equals to a function of theta, something like r equals to sine of 2 theta, or for example even r equals to 5. Or it could be f of r and theta equals to 0. For example, r squared plus sine theta equals to 10, something like that. Okay, so if you have an equation that has just r and theta in it, it is called a polar equation. Okay, let me give you an example. What is r equals to 2? Okay, so I have r equals to 2 and I'm really comfortable in Cartesian. So I'm going to transform r equals to 2 into Cartesian. How? I'm going to say that r has this equation, x squared plus y squared, square root of that. So r is equal to 2. 2 is equal to square root of x squared plus y squared. So 4 is equal to, I'm going to square both sides, equal to that. So what is this? As you see, it's equation of a circle of radius 2, like this, x-axis, y-axis, and this distance here is 2. This equation is for r equals to 2. Basically, let me give you a recall before we go on. So equation of a circle of radius r, and if the center is 0, equation would be this: x squared plus y squared equals to r squared. Okay, so if we have radius r and if the center is for example at a and b, then the equation would be like that: x minus a squared plus y minus b squared equals to r squared. That's equation of a circle. Okay, so that's why I say that this is the circle of radius 2 in the center origin. Okay, let me give you one more example. Example is this. For example, theta equals to pi over 6. Okay, this is the polar equation, and I want to see what is that, x and then y. So you see that r is free in here. I don't have any restriction on r, so I'm gonna say that this equation theta equals to pi over 6 is actually all the points r and theta such that the polar angle is pi over 6 radian. Okay, so what is that? I'm gonna say that let's assume that this is pi over 6. I'm gonna make it like, I'm gonna tilt it a little bit. Okay, so this is the angle pi over 6, and then r is free, so I'm gonna say, for example, this is 1 and pi over 6, and this point in here is, for example, 10 and pi over 6. You see? How about on the opposite side? On the opposite side, for example, on here, this is, for example, negative 5 and pi over 6. You see? So the whole line in here, okay, would be theta equals 2 pi over 6. The whole line in here, on this side would be r positive, on this side would be r negative. Okay, let me give you another example. What is the equation of a circle of radius 1, center at 1 and 0 in polar coordinates? Okay, so let me graph it first. X-axis, y-axis, and I have a circle like this. The circle has radius 1, but the center of the circle is at the point 1 and 0. Okay, and the radius is actually 1. Okay, so this would be that circle. Equation of that, so equation in Cartesian is what? It's x minus let's go back to the recall. X minus 1 square plus y minus the y coordinate of the point square equals to r square, and r is 1. So that's equation of this circle. Let me simplify that. I get x squared minus 2x plus 1 plus y squared equals to 1. So this and that would be cancelled. I get what? I get x squared plus y squared equals to 2x. Why did I wrote it like that? It's just because it would be easier to transform it into polar. How do I do that? Well, this is the Cartesian coordinate, and I know that r is square root of x squared plus y squared, and I know that x is r cosine theta, right? So this part in here would be r squared, and then x here would be r cosine theta. So you see, that's why I get r squared equals to 2r cosine theta, and the r's would be cancelled. I get r equals to 2 cosine theta. That's equation of this circle in polar coordinates. If I want to basically use this is by equation. This is algebraically way to show this circle in polar. But if I want to do it geometrically, I'm gonna say what? I'm gonna say that I'm gonna graph this, and I'm gonna say that I have a ray like this, and every point on that circle lies on what? Lies, this is r, right? This is the distance from the origin to the point on the circle, and as you see, r equals to what? R equals to 2 times something. Let me see. This angle that I have in here would be the right angle, and then I have theta in here. So equation of this line in here, r, using this right triangle in here, r would be what? Would be hypotenuse times cosine theta, just using this right triangle in here. So r equals to 2 and then cosine theta. And notice that theta in here should be from negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2, just to make the whole circle. Okay.